Today, we're going to be talking about software development techniques for PCB design. I don't know if that means anything to anybody. Let's just start with this. How many people here are familiar with software engineering principles such as code check-ins or continuous integration, continuous deployment? Wow, more than I thought. Okay, by a show of hands, how many people are familiar with software engineering in general? It's just software. Oh, excellent. How many people here know software engineers? Excellent. For the record, just for the camera people, for the record, anybody who's watching this, we got a show of hands for the questions here. We got the whole room put up their hands. Okay. So we're going to talk about taking software principles such as continuous integration, check-ins, things like that. So we're taking software engineering principles and applying that to the electronics design. In doing that, we're also going to be, David is my co-presenter here, and in doing that, we're going to be talking about integration with some other products, not just Altium Designer, but Altium Concord Pro, which was formerly Nexus, which was formerly the Vault, which might turn into something else. I don't know. But the name right now is Concord Pro. Anybody who's familiar with the Vault, it's the Vault. And how we integrated everything together. Our story, my story, it started originally at the previous company, which is a NASA Jet Propulsion Laboratory, and then eventually migrated with me to the company I'm at, Glen Air, in Glendale, California. So we're going to talk a little bit about the overview of what software development techniques are, what are these different type of techniques that people use in software, what are the different type of systems, the workflows, things like that, and what were the problems they were trying to solve as software engineers, and how they solved it with the systems that they used. And then we're going to discuss some of the problems that I personally face in my current company and previous employments, previous companies, the problems that we had on the hardware design side. And then David's gonna go in and talk a little bit about Concord Pro and how some of those problems can be addressed using Concord Pro and some of the systems within that, and then how we took that to the next step in automating everything using all the software solutions, layering on top of Altium Designer and Concord Pro. And then finally, I'm going to be giving a quick demo. It's just going to be slide-based, but it's also, in terms of watching this video later, the demo will not be on the video. It's just going to be shown right here, just because some of it it's not restricted material, but it's still somewhat proprietary, so we don't want to send that out afterwards. So let's get started. Let's talk about the overview of the software development technique. So a few things here. The challenges that software engineers were facing, the build systems, basically the concept of what build systems are, the concept of continuous integration, continuous delivery or deployment, and finally, how to take all of these different solutions and put them in software engineering applications, which we'll talk about. I'm going to be leveraging one company's solution, which is the company, for anybody who's familiar with Atlassian, they do different products called Jira, Bitbucket, Bamboo, stuff like that. So how we took, how they treat build systems, continuous integration, deployment, delivery, and then how they created a software suite of tools in order to achieve that framework. And then ultimately how we do that with electronics design. So here are some of the challenges that software engineers face. These are some of the challenges that we faced when we first came into our software engineering department and basically had to restructure, reorganize some of the code. One issue is that the build, like compiling the code, creating the executable, sometimes it can only be done on a single person's laptop. And so we had this issue where the person had left the company and they were still building on this old Windows XP laptop from probably 5 years before. And when we were about to upgrade the system, somebody said, no, don't touch it. Don't touch it. That's the only thing that can reproduce the executables, the binaries, in order to load onto this microprocessor, in order to build that environment, that software environment. So that's obviously a problem. That's a challenge that a lot of companies face. I'm sure none of you have ever faced that problem before, but that's a challenge that we face not only at my current company, but we faced it at other companies that I've been at, and other friends and coworkers have faced in other places. Another one is everyone modifying code on production machines. Again, I know nobody here modifies code in production. Of course, nobody does that, but we had servers and machines where people were going in there and modifying it. Obviously, that's a big no-no. Traceability between the code changes and the business requirements. So if you're doing firmware or you're doing high-level software, and again, we're going to extend it into hardware design, but having that traceability, especially when you're talking about like anybody familiar with like a military or medical industry, having like DO 160, for example, for military, DO 178, for the aviation and for military standards, things like that, AS 9100, being able to have traceability, especially if you're going into space, aerospace, it's really, really, really critical to have that traceability. Code reviews and releases, that was virtually non-existent. Okay, so here's how they address some of the issues. Build systems. So these machines are dedicated machines that compile your code. This is no longer somebody's rogue laptop with Windows XP full of Trojan horses. I mean, this is a system dedicated. It's a system that's replicated. It's a system that can be turned on, turned off. It could be in the cloud. It could be on a cluster. It could be a desktop machine. The key is that you have these machines to compile and then run testing on that code afterwards. So that means that if you have, for example, one of the projects that I was working on previously, we had long compile times, place and route times for FPGAs. Sometimes it would take like an hour or 2 hours. And if you're trying to place and route on multiple FPGAs for multiple targets, then that could take a couple hours sequentially. So what you do is you have several build systems, and they can farm out to compile farms. When you have repeatable build systems, or anybody who's familiar with like Dockers or things like that, you can put those into clusters. You can put them on machines. You can repeat all those builds anywhere. And then again, it also helps with documentation. It helps you create a log for everything that you need. So build logs and creating the hex file, the binary file, the bit file, whatever it is, you can create those executables. You can create that on that system. And if there are any compile errors or if there are any issues, you have a full log of that. You don't need somebody sending an email with an attachment saying, here's my .log. Okay, it just happens right then and there. And then again, repeatable source of truth to avoid that wretched laptop that's now in the gutter, thank God. Continuous integration. So the purpose of continuous integration is to ensure that anytime somebody commits their code to what we call the master branch, it won't break that main branch of code. So essentially what we do is something called unit testing, or testing that full system level testing, which is people will commit their code into the server, and then it'll take your changes, test everything, and integrate it into the current branch. And if anything fails, it'll report that back to the designer and possibly the team to say, hey, this person's going to break your code. Do not allow them to bring it in until they fix this or fix that. So that basically ensures that anybody who's going on the production machine, you won't have any unintended consequences when they're going to go change the code on the production machine. And again, we're gonna get into this on how this, all these things that we're talking about right here is how it relates to the hardware side of things and PCB design. Continuous delivery and deployment. So delivering and deploying releases to customers for review. So a customer could be your team, it could be somebody outside, it could be somebody inside. So the whole idea is every time you do a commit, it goes through the continuous integration, it gets built, it gets checked, okay, it's ready to go. Now it builds that binary, it builds that executable, it builds that bit file, whatever your target is, and it deploys it or delivers it to some space. So if you ever see like open source projects or other projects online where they'll say like nightly builds. So a nightly build is basically somebody doing deployment or delivery that it automatically compiled everything, it tested everything, and now it's being deployed to you, the customer, so you can get a nightly build. So again, we're going to talk about how that translates into the PCB design process. So applications and software engineering. So what are the tools commonly used for using these type of systems? So just by a show of hands, how many people are familiar with Jira? Wow, okay, that's impressive. Okay, so we've baselined our whole company system and what we're doing here with our design process on Atlassian products. So how many people are familiar with Bitbucket by a show of hands? Okay, about half the room. Bamboo. Okay, just a couple, good. And Confluence, anybody? Okay, about half. Okay, Confluence is just documentation. We're not really gonna get into Confluence. Okay, so this over here you can see is a Jira ticket. And this is, a very basic ticket. There isn't even a description, but this is just saying, okay, there's some issue in this was our web development. And so our web server that's running a whole bunch of series of web applications. And so this is saying, okay, this is the issue. There's not a lot of information. We have a help desk ticket that's linked to it. But you can see over here the development tab. And so in the development tab, it's saying, okay, somebody has opened up a branch off the master, and they're developing on that. They've committed 4 times, so they've done 4 commits of code changes. They set up a pull request, meaning a code review, that's been merged, which means somebody has accepted it and pushed it into master, and then 1 build. So this means that it's built, it's done its testing, it's good to go, and it's got the green check mark there. So this development panel is easily integrated. Once you use all the different Atlassian tools, they just all kind of come together. You can still use Jenkins and GitHub and all the other third-party tools. They integrate pretty well also with Jira. You just open right out of the box and they all hook up together. Then the last thing is deployed. So deployments to development and production, that means we deployed it to the production server. Nobody went on the server. Nobody's touching the server. Nobody's logging into the production server. It's automatically going whenever we hit the button or we have it automatically set. So code reviews, when we talked about like a pull request. So code reviews is basically people going through the code, adding comments, things like that, making sure that there are no issues. It's just a standard way of doing things, of checking each other. And then this is an example of what builds look like on every commit. So each one of these builds are triggered by people committing codes. So every time somebody commits a code, commits to the repository, it goes and runs those tests and those builds and things that we talked about. This is just to give you an idea of how these systems work. Okay, so now that's the software side of things. Now I just want to go into some of the issues on the hardware side of things. So first of all, here are some of the challenges that I've seen in some engineering capacities, that mismatch between the package release and the design file. Has anyone here ever seen a package, of course not within your company or within you guys working, have you ever seen a package go out to a contract manufacturer that didn't necessarily link to your release system? Has anybody ever seen that? Okay, we got a few shy hands. Of course, I don't believe that it came from you guys. I don't even know what companies you came from. That's okay. So that definitely we saw that. Files would be in some sort of release system, like maybe a shared drive, at best a PLM. But then when it goes to a CM, we sometimes have a mismatch. So we had one time a board came back. We turned it on and we're running it, and something is completely messed up. And nobody can figure out what's going on. And they went back, they looked at the release files, they looked at the Gerbers, they checked everything, looked good. They went to the CM, they asked the CM, where do these files come from? And they said, well, send us back the files, the Gerber files. They discovered that one of the inner layers, 2 of them were replicated on top of each other and then started to, one of the layers was actually missing. And so the middle layer was completely gone, and that's because somebody had generated the package on their computer and then pushed it out to the CM. So again, think about the linkage here. Somebody is generating the package, meaning like the files, and then sending it out. So it's just like the parallel is somebody building the code on their own machine, on their own system, and then it's going out to being deployed to the CM. So that's that parallel. Last minute BOM checks. Has anybody here, by a show of hands, dealt with component availability issues in industry? Wow, okay, just for the record, pretty much everybody raised their hand. Okay, so last minute BOM checks have become a necessity. Especially for, at least for me, I've seen capacitors, really, it's very difficult to find ceramic capacitors. We'll have, just to give you an anecdote, so we had, our purchasing department is in a different building. And so it became such a dire situation. Every time we would try and order a reel of capacitors, by the time we sent the request to the purchasing department and they went to order it, which was a couple hours later, the parts were already gone. So we physically moved one of the people from the purchasing department to our building so she could full-time just buy reels of capacitors and resistors for us. It got that bad. And she became dedicated just for our division because it was such a big problem. So this has become a necessity. It's not like something that, should happen every once in a while or when you're done with your design. And then also, package reviews, they only happen at the end of the design lifecycle. And we're going to get into that again. So the package mismatch in terms of like the story that I told you that the files in the server weren't found by the contract manufacturer. And so again, what happens is now the boards come back with incorrect routing or footprints or something like that nobody has any trace to. You have to go back to the CM or whatever. And okay, I mean, yeah, you could be more methodical about it. You could be more meticulous. You can enforce things. You could have a policeman, standing there over everybody saying, you shall do this. But at the end of the day, what if we could just remove the human out of that element and just get rid of that whole error in general, okay? And let robots take over people's jobs. Okay, last minute checks, as we said, components are out of stock. The components are out of date with the server maybe. ERCs creep in. So last minute checks, things that you don't necessarily want to do at the end of the design lifecycle. So if anybody's familiar with the waterfall method, it's basically doing your requirements, then design implementation, then verification, and then maintenance. So if you think about it in terms of design for your PCB, you're basically doing all your verification, checking that your old parts in stock, validating, doing your DFM, doing all those checks happen at the very end of your design. And so that can cause, let's say, formatting issues, there are files missing in your packages, fabrication notes are messed up, things like that happen at the very, very end that delay sometimes weeks or possibly even more than a month before you actually go to fab the board, especially if it's really, really complicated. So why can't we do a DFM review more than once? Why does it have to be the waterfall method? Why can't it be something a little bit more agile? So in terms of the package mismatch, a partial solution is using a version control system. So, I mean, yeah, you could be more consistent and more mindful about making commits and enforcing that boards get built, only to like your SVN or whatever it is. So you need to pull this particular SVN version, or you need to pull this file that's on this network drive, whatever it is. You could be more methodical about it, that's true. But especially when you talk about scaling and things like that, and if you don't have a lot of time to create all these processes, what if, again, you just remove the human out of that element? Last minute checks. So there are things, and David's going to talk about it, the active BOM, the output in output jobs, being able to check your parts in stock with the Octopart and the active BOM is extremely, extremely helpful, and that's the baseline for what we're doing. But a lot of people will, you have to open that up, and you have to wait for it to load, and you need to go and check it, and that takes time. And engineers don't want to be bothered with that every time they load up their computer to go look at an active BOM. They want something a little bit more automated, something that they don't need to think about. You shouldn't have to be able to open up your active BOM and check for parts in stock every day that you're doing designs. And then the last thing is the waterfall approach. Like what we said, you could solve this problem of doing constant DFM checking, but again, that requires manually generating, manually setting up, possibly even using a project releaser, but But if you check it in and then everybody has to check it, everybody has to look at it, your DFM department. So all these things, it's a very manual solution. Again, we're looking to kind of automate that process. So what we've done is I went probably about a year searching for a good PDM, PLM solution that would help us integrate. And initially, we were using Mentor pads, but sorry, I know it's a bad word here. So initially, we were using Mentor Graphics tools, and we were in the process of moving to Altium, and we simply could not find a solution that was relatively inexpensive to be able to get us up and running and do a lot of the things that we wanted to do. So what we found was that when we got at the time Nexus, prior to that was the Vault, now it's Concord Pro. It had the built-in version control system. And the library management was pretty simple, but it was fairly sophisticated enough for what we needed to do. And then also, most importantly, we were able to get hooks in for third-party integration. So a lot of the problems we were able to solve using Altium Concord Pro, but we needed a little bit more automation after that. So, so our objective was to basically take the release process, that whole release process, and automate that whole process using some of the Atlassian tools. So before we go into what that solution is, David's gonna take it away with some of the Concord Pro basics and capabilities.
I have the mouse, so he set this up.
Okay.
So everyone can hear me? We're good? Okay. So you can just keep the clicker since I have the mouse and the computer and everything. So for any of you that have actually been using Concord Pro, this is going to be geared more towards the basics, so I apologize for that. But don't worry, Ari's going to give you more than enough to handle after this. So bear through this section right now. But you know, the whole aspect of Concord Pro was to give a complete system for component management. Why do we use the term component management as opposed to library management? It's because it's evolving past just the basic library systems we had in the past, right? Before you had the individual libraries that in itself you had to manage those libraries. With Concord Pro, it is a holistic entity, the component itself, and it's about managing that information on a component level. So you're getting up-to-date and standardized component information for each of these, and it enables you to have a level of automation for your design data as well. So with that version control that was mentioned, you actually have that project management. But the key for the project management is that you're actually able to leverage the component management capabilities to their full effect. You're able to see where your components are being utilized, how they're being utilized, update them as necessary throughout the system, and fully manage the templates to their maximum capacity. And it gives you a level of standardization to avoid this package mismatch, right? If you have a certain enforcement for all things that are being created, you ensure that everything is up to standard, right? That's why the word is standardization. And you can make templates for all types of files in the system. But again, the main core is to focus on the component aspect. So what we're going to go over briefly is just searching for components, going through quickly making a component, and seeing validation of these components in a project.
When the models are built for cyber vendors, do they build them at nominal dimensions, or do they offer you the opportunity to have min or max?
Yeah. So as you can see in this picture right here, the information is pulled from the Octopart system, right? And for the majority of models, you actually have all three, right? So you can see right here, we pulled in, I guess in this picture it's a capacitor, and you have all three and you could set the default. So for placement, you set the default for that placement. If you want normally for that footprint to be, or whichever one you want to be, it will be that upon placement. You are also able to change it before that release. So what is a good practice is you, for example, will download these as a baseline for a component, get the basic parametric information from the Octopart system, and then you could add your own information on top of that if you would like to create a second revision with your own models. Right? A lot of companies are very particular. You'll see how easy it is to actually update all of these components. So you don't actually have to get stuck with these models. Some people don't like to use other people's models. I understand. Who doesn't like to use other people's models? See, that's Ari's like, I don't know if I should raise my hand. It happens. It's completely understandable. But what this gives you is a nice little baseline, and you could modify what's already there, right? For example, here, you could just remove the model and fix that, right? You already have overall a good example. Yes.
Nice little button that says add simulation. I know Octopart is doing a very good job of giving us the parametric information and the model information. Is there anywhere that Concord, Pro, Altium, Vault, Nexus, whoever you would call
Insert name.
To get the simulation models from? Or is that just a placeholder for later?
You can input that yourself right now, and we could talk about that after this. We have people here who would like to talk to you about that, myself included, but we'll talk about that later. As I was saying, you have preloaded information here. It is managed by component type, so you have it set up by categories. You can standardize by the type of component. I've seen a lot of people have subcategories, for example, by package size. So they'll have resistor, but they'll also have subcategories to have different types of parameters based on the different package size. So that's all customizable to whatever you would like. So if you want to be super strict, you can do that. We include over 690 components in a sample data set, and I believe it's about 20 different types of component templates on installation. If you want, you could disable it. As we were talking about issues with the package itself and the component issues, last-minute bomb checks, component validation is really important, right? You have to make sure that the component you are using is up to date, that it is the latest revision. What the system allows you to do is make sure that if someone has made a change at all, that you can easily identify that a change has been made and navigate to that mistake and make that update if you would like. It is not mandatory. You can change the severity of the issue. I will be doing a demonstration later. I have upped the severity of my out-of-date revisions to be a fatal error, so it's nice and easy to see. There's also the concept of state. So there are lifecycle states. Each component has its own lifecycle state, which is also something you could define as well. So you can define if a state can be utilized in a design. So an obsolete state, for example, could not be utilized in a design, and or you could hide it from view. So perhaps you don't want certain people to see an obsolete component, and you could hide it, and that's all definable in the preferences. As I was talking about the statuses and life cycles, in the components, who here is not using 19? There's a couple. Okay, so the components panel was added in 19. It kind of gives you an interface into, just seeing all the components together. It makes it a lot easier to see everything. There's an information panel, which I'll go into more detail about, but you get the lifecycle definition really quickly and the status, as well as stock information. So you can see here the first square that I've circled in blue is the state. So you see this component is in a draft state. And you can also see there's a manufacturing life cycle. This information is an estimation based on the information we have pulled from different suppliers, right? We see if people have been purchasing this item often, this component. Is it a new item? We recommend, maybe it's not recommended for new designs. Maybe it might be end of life soon. So this is a recommendation. Don't automatically be like, oh, it says don't use this and just instantly not use it. Use it as a guidance, right? But again, guidance. We're working on improving it and making it more accurate with, yeah. But for right now, just make sure that you really check a little bit more about it. If it's a component that you would really like to use, and it seems like it wouldn't be a good fit, maybe research it a little bit more and see if there is good availability. On top of that, you have the ability to define alternative part choices beforehand. This really helps alleviate those issues with the last-minute BOM checks. I think it's pretty self-evident due to the fact that if you already have lined up different components that are fully defined, it makes it really easy once you make that BOM check during your process. You have a part that you can just swap in, right? You can do this in active BOM, but this is done on a project level, right? So you can make these decisions. However, it's not going to carry over across designs. So if you do this on a component level, anytime this component is used in a design, you know that it can be replaced with this alternative. So it's really nice to have this choice. And you can see that you can define this by manufacturer part number, and you also have the associated supplier part numbers, which it makes it really nice to be able to have that choice to really switch over. Yeah, it's not something I've ever really had to test myself. So, and I think it's something we could talk about after. I think that'd be. Have you?
Yeah, there is a way to do that when you generate your static BOM. It'll automatically take your alternate part choice and make it your primary. And make it your primary, and then it'll lock that whenever that goes to the CM or whenever you release that static BOM. And then when you generate another static, I know this because I just created a help ticket on it. And then when you generate later, when it comes back in stock, you'll see that'll be swapped out for your primary part later. And then your alternate will then go back to as alternate 1 or alternate 2, whatever it is.
Okay. In the component search, as I was mentioning, the components panel introduced in Altium Designer 19, you have the ability to search by component category. We have added the ability to filter by parametric ranges. we'll go into more depth in a little bit. And you could also compare the differences between two components to quickly see the differences. You'll see them in red if the values are differing, and they'll just be white if they are similar values. And this type of comparison is only available with managed components that are on a server. So, Concord Pro, Altium Nexus, and in the future on Altium 365. As we talk about Altium 365, you'll understand what that means in the future, but essentially it will be Concord Pro running on the Altium 365 platform. But that's all we'll talk about for now. So we have the model and parameter downloads. With the manufacturer part search panel, you're actually able to. Has anyone used the content vault before? Yeah. So this is the best way to access the content vault now, the manufacturer part search panel. All of that information has been put in here directly. All of the models that have this little green right here icon are those old content vault components. They have all of the model information, and you could download those. If you have a Concord Pro instance, you can acquire them, which that means is you pull in all of that information, and then you could customize it. If you want to put your own, models on it, change up the parameters, you can do so if you wish before you release, and you have a nice little baseline there. And again, the key here is that you have the templates, which give you that standardization, that automation, so that you have no mismatch in your packages. In the properties panel for the component, you're actually able to see the state again and the status of the component. You can easily replace the component, and you could update the component. Simply by clicking on the component, you can find a replacement, make a comparison of the two components, and see where it has been utilized. So the where used functionality is very powerful. As I mentioned earlier, the project management aspect is very important, but the thing that really brings it to the next level is the fact that you have that component management aspect to see how these components are being utilized throughout the system, right? You can see if a component has been used in a design in a positive manner, or if it has caused a failure, for example, in a design. So it gives you that level of information so that you don't use that again, perhaps, and you could identify that with a life cycle. If it's a dangerous component, maybe, or you can do different things. So it's really important to have this where used functionality, and you could actually navigate to the project from the where used section. Verifying component status with ActiveBomb, you can see so currently you need to add these two sections in ActiveBomb. If you right click on the columns, you can do select columns. And you could add your revision status and your revision state. So just remember to search for revision. Any item, anytime you're doing a column type thing, there's like a little gemstone. If you see this little gemstone, that means it's like a managed server type parameter, right? So just remember that. So when I'll go into it later. I'll just show it. It'll be easier than trying to remember this little gemstone thing. But and just add this revision status and revision state, and you can see if things are out of date. You can see if something's obsolete, perhaps, and make the replacement here in ActiveBomb. The idea of ActiveBomb is to not have it be all the way at the end of the process. Kind of what you were saying, Ari, that a lot of the a lot of these things are only done all the way at the end. The idea with Active Bomb was to create a system that is interactive and, well, active, right? Throughout the design process. You know, it's a little cheesy, but right, you're doing it throughout your process. It's
Does your design, when you go through this process and you automatically find that the preferred is not there, does the design automatically get updated with the alternate part, and then you regenerate all your output files?
Yeah, so everything's connected. There are certain times you have to do things like refresh or something, but there is connections.
On the fly, or do you have to run the ECO process
Yeah.
to make that happen?
I believe to replace the component, you have to run the ECO? Yeah, you have to run the ECO. Yeah.
For stock when it's not available?
No, to replace the component.
Well, I mean, all of a sudden I had to go with the alternate
Yeah.
on this Active Bomb on the fly stuff, right? But now all my files have already been generated, but they're generated with the preferred part. It takes time and effort to go all the way back to the schematic, because this bomb is one thing, but the schematic has to agree with what you finally put out. Do a good ECO.
Yeah. We can take a look at it later. I don't recall right now off the top of my head, but we're gonna do a demo in a second, so we'll try it. We'll see. So then the last thing was the project releaser, and this goes to that project mismatch again. Creating a template for your out jobs gives you that consistency. Packaging it for the project releaser, again, gives you, it's something that is going to be consistent. It gives you that level of standardization that you're doing it continuously, and then you could release it to Concord Pro, and it is controlled within that system, and you can have the different releases to compare them against each other, and actually navigate between them. So it gives you that nice level of consistency to make sure that you are releasing the same information every time and you're not missing anything, or you're not releasing the wrong version of something. Combined with the version control system, you are guaranteed to be releasing the right instance of and right revision of all of your things. So from here, I'm going to do a quick switch over, which is not great right now. So is that like another screen? Okay. So, as I mentioned in the sample data set, we have a multi-board project with 5 sample designs. This is one of the boards. So what I'm doing here, I'm compiling the design to see some of the different errors I have. As I mentioned earlier, I kind of elevated the different issues I have. So I have 2 big issues here. I have the component revision is out of date. So I can navigate to that. I can click on it. And there we go. That's updated to the latest schematic symbol. And now I can just do an ECO, and if the footprint changed, that will be updated as well. That was pretty easy, right? I didn't really have to do much. And it also gave me,
We automatically swap the model
yeah,
activity
yeah.
because of Active Bomb.
No, because of Concord Pro. You could also do that in ActiveBomb, but this is how to do it during your design process, like if you're not using ActiveBomb. I will also show you how to do it in ActiveBomb, but I just wanted to show you how to do it here. The other concept, as I was saying, was you are not allowed, I have disallowed the use of obsolete components. So you can see the status is that this is not applicable to my design. I cannot release this design with this component. It would not allow me to do that. I'm actually going to update to latest, see, and that one was a little bit easier to notice because when I updated that, I decided to make it a different color so it'd be really easy to notice that update of that symbol, right? It's blue now, so you could, yeah.
You've been talking about Concord Pro and
Yes.
you've been trying to integrate
Nexus server.
we're trying to do revisioning of PCBs.
Okay.
So it's really to do with Nexus for subject code, and Nexus is a different product that's like special subject code for your company.
Okay, so I'll rewind it. I'll rewind it for people. Altium Nexus is a solution. What does that mean? Because no one knows what that means. Because that's not a word people use. What that means is it's not just a product that is sold by itself, right? It is the client, right? Like this is a client. It is the Nexus server, and it is the custom deployment of that. So that team talks to you and your company about your needs and how to solve your specific needs, and they do all of the installation and all of that.
So let's say that you want to have a managed server that you manage
Yes,
version Concord Pro is the same.
yes. So if you had previously bought Nexus server, you would use Concord Pro now.
So the version control on Nexus was at one point SDN, then it was Git. But it is the back end. Like,
It's the same thing.
Yes, it's just the next version.
We had Nexus before
Nexus server.
Nexus server, right? And then
Oh, let's just be consistent, right?
when we had the actual it really was just the logo moving over.
And
It's just the next version.
there's also
Customized life cycle and the approval life cycle process and who can approve and when they can approve, that has been taken out of
Yeah.
Concord Pro. Otherwise, it's the same thing.
Yeah.
That's the thing
Yeah.
that's now in only the Nexus service. But otherwise, yes, it's the same thing.
The key thing of Altium Nexus, the solution, is process management. If you do not need process management, then Altium Designer plus Concord Pro will give you what you need. And you could manage it yourself. Yeah. You're welcome.
And you can actually also check the whole release status thing without using that.
Yes, you can, but we are not going to talk about that. So following up, so this component and this one are the same, but I'm going to update this one later through ActiveBomb. From here, what I'm going to show is in the components panel. As I mentioned earlier, yes.
I have a question for you. You said it was an obsolete part, right? And you put an update button, and all of a sudden it wasn't obsolete anymore.
Yeah.
What did you actually do? Apply it.
So that the life cycle state of that revision was obsolete. It would have been easier to, you have each revision, and each revision has life cycles. So that revision was obsolete. Revision 1. So I went to revision 2, which was not obsolete.
So you have to suppose that modify in some way?
Yes.
Actual parts are obsolete.
Yes. Yes. If the part was obsolete, you would then make a new part. And you would have to replace it. In this case that I made up, that was not the case. Yes. But if I wanted, if in that case, since this is the same one, if instead I wanted to replace it, I could click this and search for a component that would replace it. And I could compare the two components. Right?
Now, whose database is this going to? Your internal database or a database that is supplied by all of the
Can you rephrase the question, please?
So we have disk key, we've got Mouser.
Okay, so the system is the Altium parts providers,
Yes.
right? And
They're interactively talking all
Yeah.
the time, interactively
Yes.
With your server.
Yeah.
Now, if you've got a firewall, that's going to be quite a time.
Well, how do you now get supplier information?
Through the firewall,
Yeah.
I can
You-
talk to Altium, whatever that
Yeah.
actual address is.
Yeah. You would do the same thing.
The same kind of thing.
Yeah, because it's just the Altium parts provider. So whichever method you use, it's the same method.
Does this use the cloud and all?
Not this version,
David, if I may.
not Concord Pro.
So okay, basically you have your server in Concord Pro, and that sits behind a firewall. You open up a port to basically do HTTP communication back and forth to query the servers from Octopart to basically get parts information. But your part metadata, everything that's sensitive to your company sits behind the firewall. That'll never go to an external server if you're using Concord Pro. Altium 365 and all this other cloud stuff is for the cloud.
That's a different
Yeah.
product.
But this over here sits in your firewall on your server.
This
and
is
it only-
on premises
Right.
for you.
And the only information it's getting is the parts availability information from Octopart and the metadata.
Is there an issue with deploying this on like an Amazon server or?
No.
That's our problem, we can't use them.
Yeah. Yeah. No, that's why it's on premises, and you install it locally.
Yeah, but when it talks out to the
Yeah. No.
talking directly to them or to their Amazon cloud?
No. It uses the Altium parts provider, which, if you're already using the supplier information, it's using that same system, right?
If you want, we can talk about it afterwards, because we have the same restrictions in terms of ITAR and all that other stuff, and we can't
Yeah.
go to, so we can talk about it after.
Yeah. Okay, as I was saying, you can make that replacement here, or you can make that comparison. Components panel. You can make the search. You have the categories. You can search for a parametric range. You can favorite parameters, so that when you're in this area, you know that you're always searching for value, for example. So I favored it, so it's always there. Let's say 50 and So I have two. So I have these two, and I look at the difference between the two, and I mean, this one has 19,000, so I'm going to place that one. You can see it's just that simple, just right-clicking on it, click and place. From here, I wanted to show the active bomb area, refreshing this information. So we still have that one component that is out of date. And from here, let's do that change that you asked about earlier. Let's see what happens. I don't believe I have a good alternative to this component, so I'm not going to look for one. I'm just going to pick one at random, and I'm going to replace it. Yeah, so it runs an ECO if you do it through this system. And you can see these are some from the ones I changed earlier. Of course, there are other aspects that need to be changed as well. So there's some parameters that need to be added, some parts that need to be replaced and modified. So I execute the changes. Okay. And then the last thing I wanted to show was the project releaser itself. And you can see here you have the different types of projects. So who here has not used the project releaser before? Okay. There are, quite a variety of, you could release this to different areas. You could release it as a file or as a zip. Here, the idea would be to release it directly to the Concord Pro server. You would prepare the information, and you get details to all of this. You could configure, as we talked about earlier, to make sure you don't have that mismatch with your package. We have the templates for all of these different types of releases. So we have one for the fabrication, and this is all configurable in the options. So I go to my options and I actually say which one goes to which, right? And I say where to release it, folder, zip, Concord Pro server, and I also give it the naming scheme that I want, so that I maintain that consistency. So I'm not gonna actually do that release because it'll take a little bit of time and it's not gonna really add anything for you to see. Yeah. No, you do. Those are, that's what that is, right? Those are just in conjunction. So you are using the project releaser, are using out jobs. Yeah. You just have to modify things slightly. So it's like upgrading it to work with the system, right?
This is effectively calling your out jobs. That's what it's doing.
Yeah.
Yeah. This is a script that's calling a whole bunch of out jobs and saying, okay, go run this out job, that out job, that out job.
Yeah. That's what the project releaser does, and the whole thing is about actually making templates out of those existing out jobs. So you would release those those out jobs as templates, and then you would make a project releaser template, all of that. So yeah, it's just a little bit of extra effort on the front side but then it allows you to have that consistency with that standardization later on. So now that we've gone over the basics, just a quick review. All of the previous individual types of libraries, have all been consolidated. All of that information comes all into this ecosystem of Altium Concord Pro. What was not shown today was the ability to have the MCAD collaboration. I actually have a talk tomorrow with Linda Mazzatelli from 2 to 4. If anyone's interested in learning more about that, we will also be talking about it through Altium Concord Pro. Of course, that is supported through Altium Nexus, but I focus on Concord Pro, so that's what I'll be talking about. And the whole idea was to get all of this component information to have this unified model all in one place, so to make this all easier. As we mentioned, the key release process goals is to convey all of this information to reduce this tedium, increase the efficiency, and make everything consistent and valid at all times. This is going to reduce a lot of the issues that we were talking about earlier, and it will support the maintainability and the deployment of this to get first pass success. From the 3 main issues you mentioned earlier, I think we pretty much solved the mismatch between the package release and the design files. A lot of the last minute checks are solved with the ability to effectively manage your components, replace them easily, find alternatives for them, do quick releases of new components. I was actually going to show the release of a component, and I got lost with the question. So do you guys want to see the release of a component, or well, we can just do that later. We probably will have time, so let's just get it. You can release components, surprisingly. Package reviews are the main thing that it's still kind of an issue. So let's take a look at what you've added on top of Concord Pro to make this a little bit easier.
Okay, thank you, David. Okay, anybody who needs to be there? Everybody? Oh, okay. Let's get back focused here, back on the software side and some of the problems that we're facing. So again, we had all these issues with the team, with the people, with the way that we were releasing things, and so now we want to remove the human out of the element. We want to kick them out there and let them focus on design, let them focus on doing the engineering, let them focus on the layout. And so now we want to get everything just in an automated fashion. So what are we talking about here? So let's take the package generation. Let's take the Gerbers. Let's take the ODB++. Let's take the schematics. Let's take whatever it is, the BOM file. Let's have it done in the background. Let's forget about the whole story about, oh, well, I need to ask my PCB designer to throw a package together for me. Oh, we can't send it out for quote today. The package designer is, the PCB designer is left early today. They can't put together a package. Things like that. So another thing is the delivery of these packages to the people who can check them at any time, at any given state, at the latest revision of what we're committing to the server. So again, we want to give it to people who don't necessarily have access to Altium Designer. Shh, don't tell marketing that I advertise that. And then the last thing is the automated checks. Is the automated checks for the BOMs, the ERCs, the DRCs, everything like that. And then if we can do component parameter checks, things like that in an automated fashion, that would be a little bit of a bonus. So let's dive a little bit deeper into it. This is again applying all these software principles, all these software systems into the hardware side. So are you guys ready? You fasten your seatbelts. Okay. All right. Let's do it. I'm digging the excitement. Okay. By the time we're done, you guys are going to be just as jazzed up about this as I am. Maybe not, but it's cool. Also, another thing, a side note before we get into it, something I want to throw in here, a little bit of the backstory. Like I said, I spent like a year investigating different PLMs and PDMs, things that would do all of this for us. It seems kind of trivial, and there are software solutions out there that'll do it, especially from Mentor. But it'll cost you like sometimes, I mean, I saw it with some of the previous companies that I've worked at, is I've seen it costs sometimes hundreds of thousands of dollars. It'll cost you a bunch of servers. It'll cost you a whole IT team to set everything up. It'll get you one or two software developers to throw everything together. I want to just impress upon you, I want to express to you that basically out of the box solutions, we were able to put the system together with effectively one or two scripts, a couple hundred lines of code, and a couple days to prototype the whole thing, which normally a system like this would take months to get up and running because I saw it. I saw how we tried doing it with other tools. Okay, automatic package generation. So setting up, again, we don't want the build machine, the people who are generating the code, right, on their machine, who are the laptop is Windows XP, virus, full with Trojan horses. We don't want to be building binaries on that computer. The same thing, we don't want to be generating packages and sending it to the CM from somebody's rogue laptop. We're done with it. We had that problem once, we never want to have that problem again. So what do? We set up our output jobs, and I'm sure most of you are familiar with output jobs. We set that up to occur every single time you do a commit. A build system, basically a computer, a server, or multiple computers, turn on, okay? Every time you do a commit, every time you right click and just hit push to the server, which you should be doing multiple times a day, or you could do it on a nightly interval, which basically go in and generate and run these output jobs for you using a bunch of scripts, which we'll get into it. Eventually what you can do is once you've built those output jobs, once you've built those scripts, those can become managed within Concord Pro. So only the developer, or only the person who puts together the output job has the keys in terms of revision control and stuff like that, so nobody can tamper with it. Now you have full control in terms of having like military AS9100 or the DO standards or whatever it is in terms of access control and NIST 800-171, having access control, all these different regulations now that we have, you can do that now and comply with that with fairly a very small amount of work up front. And again, another bonus that you can do is if you have a build machine that can be triggered, that can be now linked into your sales system. So an order, think about it, an order comes in and it goes and triggers your build system on something that hasn't been checked in months, and it can now go run those output jobs for you. So we'll see what exactly is it running and what is it doing. But you'll see how, again, every commit or a nightly job or any time a sales order comes in for a certain product maybe hasn't been checked for months. Nobody's been doing a bomb scrub. So let's go into it. So another thing in terms of automated delivery. So we want to be able to deliver that package at every stage for review. So if anybody here familiar with software called Valor? Anybody familiar with? Okay, about half the room. So basically it's doing a lot of checking, PCB fabrication, it can check your components. So you can take that on the DFM side, you can have this package already generated that it can now be imported even in an automated fashion into something like Valor. So your DFM department or your CAM department, whoever they are, can now take something like a board that let's say is 99% done, but you're just moving a couple parts here and there, and without even you knowing, they can now go and just run a couple DFM things and say, hey, by the way, we caught this thing, or can you add fiducials to this, or your stack up is messed up in an early stage of your design. So again, the objective here, doing it completely in a passive fashion. We don't want to generate the package. We want it to be done for us without us even knowing. And this is kind of taking, instead of a waterfall approach, waiting to the very, very end, we're taking that in a spiral method. So we just keep iterating and iterating and iterating. And so this cuts out virtually all that time at the end where you're waiting and you're checking and you're doing this, and that dance between you and the contract manufacturer it's gone. It's when the board goes out to the CM, it goes in there and you get no response. I mean, it's squeaky clean, and then they just go ahead and build it. So let's talk about some of the automated checks. So the automated checks of the bill of materials, like the active BOM, what David was talking about, instead of doing that manually, that just happens every single time you do your commit. So this is, I broke this out. This is actually one large table, but I broke it out in half and put it side by side, one on top of the other, just so you can get a better view of it. This is a custom generated HTML report that we generate internally using a bunch of Python scripts. But essentially what we're doing is we're going in and checking manufacturer lifecycle, the part, the supplier, stock, and then we're also checking the operating temperature range, because we have a range for a specific range that we want for our components. But you can check a whole bunch of different things. This is basically an example of what happens in the background, checking all your BOMs constantly. So again, if you're committing and pushing your design every day, then it's checking this every time you commit. Or again, if a sales order comes in, think about it, you have thousands of products. If you're trying to scale, a sales order comes in the background, it's checking stock automatically. In the background, it's checking out to make sure that all your components are up to date. In the background, it's checking out to make sure nothing is obsolete, like David was showing. So all of this is happening passive. There is no more component engineering department. There is no more BOM scrubbing department. That's gone. It's all done by the robot slaves, which means half our employees have been laid off. Okay, so so what happens is, I'm sorry guys, robots are taking over. It's just a matter of when, it's not if. So we should be methodical about how we program these, but as long as they're not programming themselves. Okay, so this is an example of what a report would look like. This is utilizing a build framework, automated testing framework called Bamboo. There's another very popular system out there called Jenkins, which is free. You guys don't have to pay for Bamboo. I'm not trying to sell Atlassian. It does cost only $10 if you want to start, and they actually donate that money. But this is a sample unit test report. And so what this is doing is it's saying, okay, I ran the manufacturer product lifecycle test, and I found that you have a few parts that are not recommended for new design or are obsolete. And then we also checked for stock over here, and it told us that you have this part and this part and this part that's out of stock, and we couldn't automatically swap it with your part choices because you didn't have a part choice. So that ties in terms of the part choices. It'll automatically swap it for you. It'll show up when we do our builds. It's going to create a static BOM, which will tell us, like Bryce was asking, it'll tell us that we chose this particular alternate in this point in time at this particular build number with this particular traceability. So we can always go back, and then we know which build went out to the contract manufacturer. So we know exactly which alternate was used then. But then an order comes in, let's say a couple months later, and then the original part now swaps back in. That gets sent to the contract manufacturer, but we have traceability of that because it's locked right in the static BOM. And each package generation is its own, what we call artifact. So it's just like a nightly build. You have nightly build 1, 2, 3, or whatever the date is. This would be the same thing. So your whole package is a build. And then also if you've done something, or if your part's out of stock, or there's an issue with your design, you automatically get an email being notified to you and the team. And again, it's kind of like a whodunit. It's a blame in code in software engineering. So if I submit a pull request, or I try to merge something into the master branch and I've broken the master, it doesn't just let me know. It lets the whole team know that I'm trying to break the main branch of the code, the master branch. And so this is the same thing. If I go in there and I start meddling with, David's design, and I start changing some of the parts, the whole team's going to know that I just went in there and busted everything up because they're all going to get emails. Yes, sir.
But if you're committing often during the day, to save work, and it's not quite done, or it's just like a placeholder,
yeah,
isn't that going to create a lot of noise?
Excellent question. So I disable my jobs. until I disable my builds, or I only let it notify me before I go to production and then notify the whole team. So if a product goes into production and I know nobody else is going to be touching that for a while, then I'll release it, put the whole team on it, or whoever is engineering, whoever will take this one, you're going to take that one, that's when I'd put it on. But if I'm still doing development and stuff like that, like when we talk about some of the output jobs, for example, a PCB, if I know there isn't even a PCB in there yet, I'm going to disable the whole Gerber, ODB++, pick and place file generation. I'm going to skip that, what we call in continuous, in build systems, the stage. So I'm going to disable that whole stage and say just generate schematics and do the bill of material check. So the automated check. So again, you can run anything that you can run in an output job, you can run over here, or you can do more sophisticated stuff if you want. So the ERCs can generate an HTML report, which then you can go and parse and write Python scripts. The DRCs, you can do the same thing. You can parse that with your favorite language if you want to use Ada or Tickle or whatever you want. We happen to like Python just because of all the framework and all the bundled stuff that come with the language. But you can go in there and check all of that and then review it with the team, or your team can check it. So everybody's getting these emails and they say, oh, I know Ari's out this week. Why don't I cover him and I'll go find an alternate part? Or I see that part hasn't been updated, and then maybe they'll shoot me a text or something and say, can I swap this out? So everybody can see it. Everybody has traceability. And then now what we have is all these different issues that we talked about previously can be resolved in a more automated fashion. So now I want to go into the demonstration of this. So I will cue the cameras to turn this off.